Okay, so here's the review for the final, and so I do have a little vertigo going on today, or at least the day I'm making this video, so hopefully it all goes well. So if, I don't know, we'll see. So 60 miles per hour, and remember, if it's a rate, you have two numbers at the beginning per 1 hour. If it was just 60 miles, you'd just have one number at the beginning. So since it's a rate, I have two, 60 miles per hour. And then I'm just going to make a bunch of little, multiplying things. I'm not sure how many I'm going to need. I'm going to go ahead and cancel distance first. You could do whatever you want. Miles is on top, so I know I'm going to need miles on bottom. And I know there's 5,280 feet in 1 mile. And so notice these cancel. And my goal is to get what? Feet per second. So I'm actually done. I like this label of feet. So the labels kind of tell you when you're done. So I like that one. So now I'm going to go and deal with hours. So hours is on bottom, so I need hours on top, and hours go to minutes. And again, the numbers follow the labels. So I know there's 60 minutes in 1 hour. So you want to make sure whatever this is, it equals 1. Like there really is, 1 mile is 5,280 feet. So that's 1. 1 hour is 60 minutes. So that's 1. All right, so let's see, where am I at? So hours all the way down here, cancel all the way over here. Notice I have minutes and I want seconds, so I'm not done. So minutes would need to cancel top to bottom, seconds. And so then I'm like, okay, well, there's 60 seconds in 1 minute. And again, make sure that's accurate. All right, and so where is my label at? Where am I at? Minutes, cancel with minutes. And then notice I have the other unit I want. I have feet per second. So I really don't need this last little guy. So then everything on top gets multiplied. Everything on bottom gets multiplied, and then you divide. So I got, well, maybe 3, 1, let me write it over here. On top in the numerator, 3, 1, 6. Why is my pen just kind of acting up? I think, let me try a smaller one here. 316, comma, 800. Divided by, and then on bottom, when I take this times X, the ones don't really make a difference. I get 3,600. Okay, so divide those on your calculator, and you should get approximately 88 feet per second, which is what our goal was. Okay, so we wanted to get this in feet per second, and so I did dimensional analysis, so everything canceled except feet, everything canceled except seconds. And so the math tells you what to do. Multiply everything on top, multiply everything on bottom, and then divide those two numbers. All right, let's look at the next one here. So the next one is we want to convert, 3.45 centimeters into meters. All right, so again, I'm going from centimeters, which are a tiny unit, into meters. So the decimal should get tinier. But I'm going to make my chart. These are your main metric guys. You have 3 wings on each side. Don't care, don't care, don't care. Kilometers are your big guns. Millimeters are your little ones. And then centimeters are kind of about the thickness of your pinky going crosswise. So where am I at? I am at centimeters right now. So 3.45 centimeters. And how many jumps does it take to get to meters? So 1 jump, 2 jumps. And if you're going backwards, this is base 10, so you're going to divide by 10 twice, once for each jump. So I'm going to add a 0, so 1 jump, 2 jumps. So 0.0345 centimeters would be my answer, and it's less of them, so that makes sense. All right, let's look at the next one. I'm just going to kind of erase what I just did here. Get rid of that and see if I can get rid of that red without getting rid of too much here. All right, now we're focusing on 4.5 liters, and we want to go to kiloliters. So kiloliters would be here. So how many jumps is that? 1 jump, 2 jumps, 3 jumps. Again, I'm going to a bigger unit, so I should have less of them. So I'm going to go ahead and add some zeros. So 1 jump, 2 jumps, 3 jumps, so 0.0045 kiloliters. And again, each time I jump, I'm dividing by 10, and so that's why the decimal actually moves, because when you divide by 10, you're making it 10 times smaller all the time. So this will be your final answer right here. Okay, go ahead, if you haven't done the last one or number one yet, try it on your own. And then again, you should always try all these on your own before watching the video anyway. It's just better for you. So pause it and go ahead and do the next one, and then we'll pick up there. Okay, so this time we have 2 days. Notice it's not a rate, so you just have one number to start with. It's not like the miles per hour one. And again, I'm just going to make a lot of these just to see how many I need. So right now I have the label of days, and our goal here is to get what, into seconds? So I should have a lot of them because, and that's getting cut off, but it should be seconds, because I'm going from a big unit to a smaller unit, so my number should get bigger here. All right, so I have days on top, so my pen has frozen. Let's see if I can get it here. All right, I'm going to pause a second and try to get it to work. All right, I think I got it to work here. So days is on top. Oh boy, we got an eraser here. Okay, so 2 days. Days is on top, so I know I need days on bottom to cancel. And I know that 1 day has 24 hours. So I'm going to put 1 day here, 24 hours here. And again, match your labels. These cancel. All right, so now I'm in hours, and I don't want that either. So hours are on top, so I'm going to put hours on bottom. And that goes to minutes. And again, don't just write numbers here. Think about it. 60 minutes in 1 hour. So make sure you don't accidentally say 1 minute is 60 hours. So again, now hours cancel. So now I have the label of minutes. So minutes is on top. So I'm going to put minutes on bottom. Seconds are on top. And I know there's what? 60 seconds in 1 minute. And these cancel. And then this is the unit I want. I'm in seconds. So I don't need this extra little thing. And I know I'm done. So again, the dimensional analysis tells you what to do. Multiply everything on top, multiply everything on bottom, and divide. Now, the only thing here is I only have ones on bottom. So when I multiply, divide by 1's not going to do a whole heck of a lot. So when I multiply all the numbers on top, I get that. Divide by 1 doesn't do anything. So my answer is this many seconds, which makes sense because I'm going from unit days that are bigger to seconds, which are smaller units, so I should have more of them. All right, go ahead and try the 2 order of op on problem number 2, and I'll come back. Okay, so let's look at this first one. Now, again, addition separates terms. So you have to view, this is like a $2 soda. This is like buying 4 objects that are all the same price. These are totally separate. And again, with order of op, if that bugs you, remember, please excuse, my dear are tied left to right, and add and subtract is tied left to right. It has to be that way, because if I buy a $2 soda and 4 snacks that are $5, or if I buy 4 snacks that are $5 and my $2 soda, the answers have to be the same. So you'd have to total up those 4 $5 snacks first, regardless of how they're written, then add in the $2 later. So just remember, we always total last. We always add and subtract last. So you have to view this as a separate chunk from that, because it is. All right, so we have our $2 soda. That's its own deal. Order of operations, so parentheses, yes. And inside parentheses, the rules are the same, so I'm going to multiply first. I still have parentheses, right? So I still have parentheses. So I'm still going to leave everything else alone. 10 minus 6 is 4. Okay, I don't have a math to do in my parentheses anymore, so I'm done with that. But now I have an exponent, so I still have to deal with that. So I'm going to get 2 plus 4. Everything else just stays. I get 16. Now, you can either change that to a dot 16 or just parentheses 16, because when a number touches a parentheses, there's definitely multiplication there. All right, and so now I'm done with my exponent. So now, again, multiply and divide. Let's see. So I need to do that next, because that's like buying the 4 snacks, 4 pairs of jeans, whatever that would be. And so that's what, 64. Finally, I can add up my bill, because I have all of this purchase, these 4 items that cost $16, but then I also have my $2 items. So you always total at the end. And so that would be what, 66? Now, again, you have a calculator that does order of op. Type all of this in your calculator and hit enter, and you check your answer. And if it's not 66, you need to find your mistake. All right, go ahead and try the second one here, and I'll go over it in just a little bit. Okay, so let's go ahead and look at this one. Again, add and subtract kind of separate your chunks. So in a sense, you have kind of a chunk over here and then another chunk over here. But if you do order of operations step by step, it should all work out. Do I have parentheses? Yes. Okay, right here. So I'm going to leave everything else alone. So technically I could do one thing in this chunk and one thing in the parentheses, but I'm just going to leave it alone. Add the opposite, taking away debt's a good thing, you should get 7. Now, this parenthesis doesn't really mean multiplication because it's not touching anything. So it's really, there's really a subtraction there. All right, so I have parentheses, I have no exponents. So now I'm going to multiply and divide left to right. So I have multiplying and divide here, but again, it's a tie. So you go left to right, whatever you do first, okay, whatever you see first. So this is what, 12 times 3 minus 7. I still have multiply and divide left to right, so that's what, 36 minus 7. And then finally, I only have one thing left to do, which is subtract. And so I do that last, and I get an answer of 29. Again, check it on a calculator. So type in the original. Don't type in the plus thing. Just type it in the original. Check it, and if you don't get 29, you know you're wrong and find your error. All right, why don't you flip to the next page and go ahead and try number 3, and I'll pick up with you in a few seconds here. Okay, so let's look at what we have going on here. Can't find my pen. There we go. All right, so number 3, it says, what's the difference between a constant and a variable? So constants are like numbers. 3 is always worth 3. -8 is always worth a -8. A half is always worth a half. So they're values that don't change. That's why we call them constant, but they're also numbers. What's a variable? Well, a variable is a letter that stands for a number, kind of like x, y, maybe x squared, maybe a capital A for area. But they also vary. So in a formula, I might get perimeter equals 2 width plus 2 length, but sometimes I might sub in a width of 2 inches and a length of 3 inches. But other times, my width might be 4 inches and my length 5 inches. So variables do vary, where constants don't. Okay, what's the difference between linear and exponential? Okay, so linear always go up by a constant amount. Exponential go up by doubling or a percent or tripling, something like that. So linear are always in the form y equals mx plus b. The x and the y stay in your formula always. And then you have some type of number for your slope and a different number for your y-intercept. So whatever's going up by a constant amount, so say it's going up, it starts at 80 and it's going up $5 all the time, then that would be your formula. So you have a starting amount and you have a constant rate of increase, but it's like 5 all the time. So it just is constant change. Versus if you look at exponential, maybe it's going up by, say, 20%. So you might have a starting amount. So starting amount. But then it goes up by a multiplier. So this would be 120% if it's going up. And then it's always exponential. So you have a variable up there. So an example might be that you start with $80 again, but it's growing by 20% per year. So you'd have your variable up here. So if it's, say, 5 years, you'd sub in a 5 there. If it's 10 years, you'd sub in a 10 where the exponent is. So that's kind of the difference there. What type of problems are proportional? Proportional is if you double one, the other one would scale up at doubling as well, or if you triple one. So like, for example, if you have 3 over 8 and maybe x over, say, 24, maybe my pen's acting up again here. If I scale this up by 3, and then this would have to be scaled up by 3, so that would be 9. So anything that's proportional. So things that are proportional might be like if you get an hourly wage, like in 1 hour. Boy, why is my pen having issues today? All right, let's see if I can try a different one. I think it's froze. I'm going to try. Okay, so proportional would be like, for example, in 1 hour, if you make $11, if you work, say, 5 hours, then you should make 5 times as much. And again, my pen keeps acting up, and I'm so sorry. I don't know why it's freezing. But it would be 5 times as much, which would be $55. The next question is, what are 2 different definitions of slope? One could be rise over run. One could be change over y over change of x. One could be a rate. Another one could be pitch of a roof. Another one could be grade, like a percent out of 100. So if you have like a 5% grade, you would have 5 out of 100, so rise over run. So lots of definitions for that. Okay, and I'm going to run out of time here, so I'm going to pick up with that order of op question in the next video.